All right, you guys. So I've posted with this more questions that look exactly like this one, but in your notes, highlighted in blue, created an equation in Vertex form. Could you please write that down in your table of contents, and then please start your next set of notes. You can go ahead and pause and do that, and then I'll just keep going. So Vertex form of an equation is exactly like it says. From the equation, you should be able to see the vertex. So an equation looks like, and this should be in your notes already, but let's go ahead and rewrite it. Y equals a parenthesis x minus h squared plus k. All right, and then I want you to write what the vertex is right here. And this is one of those things I'm going to check to see if you're actually paying attention. And I'm not going to write it down. I'm just going to say it. You put the negative h here, comma, and positive k. All right, so it'll be negative h and k. That's going to be your vertex. It's going to be either your vertex is your maximum or minimum point. Okay, your maximum or minimum point, and I want you to put that right here as a sentence. Your vertex is your maximum or your minimum point. So for this one right here, it's going to be a maximum point, and our equation is going to be negative because both sides point down. So whenever you have a negative equation, you're going to have a maximum, but whenever you have a positive equation, you're going to have a minimum, because a positive equation is going to look like that, right? Okay. Now, so the vertex here is going to be the maximum point, which is right here, and our x, or it's actually our h, sorry, is going to be 1, 2, positive 3, right? And the k is going to be our height, and that's going to be here, which is positive 1. So our y there is 1. This is positive 3. All right, so this is, oops, I put that in the right place, 1 right here. Okay, and our roots, if you remember from our other equations, are where they cross the x-axis. So root 1 is going to be positive 1 right here. Maybe I should use the highlighter. Root 1 right here is positive 1, and root 2 right here at positive 5. Okay. Our line of symmetry is x equals, and it's going to be this line right here. What does x equal there? Well, we already found it. Remember the line of symmetry where we folded over? It's the same on both sides. We already found it. It's x equals 3, and it's part of the vertex. Okay. All right, and our equation, we're just going to say that our a is 1 here, and we're going to worry about finding this a at a different time. Actually, maybe we need to worry about it now. Let's worry about it now. Let's write down what we know, okay? Let's write down what we know. We know that, let me put this over here, y equals a times x minus h squared plus k. What do we know so far? Y equals a x minus, what's our h is 3, and our k is 1. Now, in order to solve for a, I need to put in a y and I need to put in an x. So let's put a different point. Look at, I have these points right here, my roots. Let's use this root where my x is 1 and my y is 0. So my x is 1 and my y is 0. So now we have all numbers except for a. So we can solve for a. So 1 minus 3. Oh, you guys, I didn't put my squared here. Don't forget that like I just did. Squared plus 1. So let's keep solving. 0 equals a times, what's 1 minus 3? Negative 2 squared plus 1. Okay, and I was able to do that because that's just a number. Now I need to get a by itself, so I'm going to subtract 1 from each side, and now I have negative 1 equals a times negative 2 squared. Negative 2 squared is positive 4, so basically I have positive 4 times a. Then to get a by itself, I divide both sides by 4, okay? And a is equal to, because this becomes a whole, and I like to write it as the variable first, so I just put the variable first, that's okay. Because equals means it's the same on either side. Negative 1/4. Oh, so it's a good thing we did that because we had to find a, right? And then over here, let's just write our final equation. Our final equation is going to be y equals negative 1/4. And that negative 1/4 is important because that negative 1/4, it's the a value. When the a value is negative, both sides point down, right? So let me just kind of highlight that. When the a value is negative, I have a negative, both sides point down. That's going down and that's going down, which gives me a maximum, makes my vertex a maximum, okay? Times x minus h. Okay, we know, actually I shouldn't have written that because we know that h is actually this 3 value right here. Because what is my point right there? My point is this vertex point where my x is 3, but the 3 is actually the h, right? And the 1 is the k. And I said negative h over here, and that's going to come in handy here in just a second. So pay attention. X minus 3 squared plus, and my k is that k right there, 1. So here's my equation, right? My equations are only going to have a y and an x, and I found that other point. When I said over here that this was negative h, that's because, look here, I have minus 3. We need to take the opposite of that because it's actually positive 3, right? So that's why I put minus h to remind myself over there that minus and negative is going to become a positive. Okay, but it is really just hk, but you need to remember it's the opposite value. If I'm subtracting h, my h is actually positive 3. Okay, so this is my entire equation. So let's write down the steps that we did. The first step is, and I'll write down the 1, 2, and 3, and you write down the actual steps. The first thing I did was I found, so find, if we're doing this from a graph, this is from a graph, and we'll need to put more notes, so let's keep that open. You need to find your vertex. Okay, and we did that. So you need to put the rest of this here. Find your vertex. The second thing we did was we found our roots. Now, you don't need to find the roots to write this in vertex form, but you have to find at least one other point. So let's find, and then this should be at least one other point. That's what goes on the squiggly line. Now, if you turn this in with a bunch of squiggly lines, I'm going to know you didn't actually listen to this, okay? 3, we solve for a, right? I'll go ahead and write this all out for you. Solve for a by putting both your vertex and another point in. So you can put that down too. You're solving for a by putting your vertex and another point in. Okay? And then you rewrite the equation. Ta-da! Rewrite your equation. Okay, now I need you to have these sounds. Actually, let's do one more of the practice problems from this. I'm going to pause it and put another one up for you guys. All right, you guys, so I picked number E because it's a little bit different. First of all, our A is going to be positive. I can tell it's already positive. And secondly, there's no roots, right? It does not cross the x-axis. So what does this look like? And remember, we use vertex form when we know the vertex, and it's going to be easy. Now, I want you to keep room on your notes because we're going to do something when you come back called, and I'll write it here, because you guys need to remind me that we need to learn it in class. Piece of candy for the first person that tells me we need to take notes on completing the square. This is just a reminder up here for you to tell me. Okay? This is a reminder bubble. Okay, but for now, let's just redo this. So step 1 is from the graph, find my vertex, and that is my x is, let's see, 1, 2, 3, 4, or my h, right, 4, and my y is 1, and that's a minimum this time. My zeros, they're non-real. That's what we call these, non-real. So we have no real roots, non-real. But I still have a line of symmetry. It's right here. X equals 4. You can see it in my vertex. Okay. But we do need to find another point. Okay. So our vertex was 4, 1. Another point is, this looks like a good point, 3, 3, right? 3, 3 is another point on the graph. Okay, now let's put it into our equation. And our equation is y equals a times x minus h squared plus k. Let's put in all the numbers we know so we can solve for a, right? We're solving for a. That's what we're doing here. So y, I have this y here. That's going to be my y. And then this is going to be my x because these are the additional points. Okay? And this is my h. And what color do I have? I have a pink color. And this will be k. So let's put those numbers in there. 3 equals a times 3 minus 4 squared plus 1. So solve this for a. I'll do the next step. Let's see. Maybe you can get done before I do. Now we have 3 equals a times 3 minus 4 is -1. -1 squared is just +1. Okay, now subtract 1 from each side, and I get 2 equals just a. So a is just what? You guys were already done. A is 2. Ta-da! Now I can rewrite the equation. Now that I have my a, so I put in, I keep y, but instead of a, I now have, oh, do I have another color up here? Orange, the last one. A in my equation is now 2. So I write my equation, but I don't put in the y and I don't put in the x because I need those for the equation, right? Because it could be for any y and any x. So 2, I'm getting this from here, 2 parenthesis x minus 4 squared plus 1. All right? Now I will let you try, and it's right. It is right that a is positive because our graph looks like a smiley face. Both ends are pointing up. So I know